Sup? It was 2000s, beautiful time when everything seemed really nice and free, at least in Russia. I was a small baby boy that knew nothing about the world, and I've been scared by one thing and one thing only: space. I still remember the moment I've seen some kind of dumb documentary that described how scary the space is, and in 2 years Asteroid will hit our planet, in 4 years there will be a space invasion, and in 6 years Sun will explode and kill us all. Only now, after all these years, I've got knowledge that God sent me through the computer. I'm able to wield powers of electricity to get any answer I want. You would tell me to Google stuff, but the government controls Google and tells us what they want us to hear, so I will steal all the data from NASA, at least in Russia we say NASA, and make it our data. Sorry, my Soviet heritage speaks through me, and I'm glad that it happened, because at the end of this video I figured out a date for an apocalypse. At first we have to figure out how to steal, democratize our data. We could hack their mainframe, steal not their data, or just use an API. Yes, NASA gives access to their database, but they let you get only 20 records per request. Aha! They didn't want you to see everything and know everything. These lizards are want for you to believe that you have access to the information, but it's highly curated and hidden from us. So we have to download the whole database to really dive into it. So it's 2100 requests. I left notebooks for this on Kaggle and GitHub. I just changed the test part for false. Also, you will find a full dataset on Kaggle. GitHub doesn't allow me to upload it since it's like a terabyte. I'm just kidding, it's just half a gigabyte. Yeah. Let's look at our dataset. And here we see why it weighs so much with such a small amount of data. It's JSONs. Let me oversimplify to you what a JSON is and why it is a cool thing. For the time I prepared a GTA 6 car montage, yeah. JSON is a type of data. Let's imagine that you want to save info on all of your friends like your government do. You start to fill up a table, and at one point you understand that you know different things about different people. So a lot of columns look like grated cheese, and to store data like this is dumb. Here comes JSON. It's a storage based on key and value. For example, let's record data in our government spy John. Yeah, hi John. We'll use some unique ID here for a key and another JSON as a value. In a second JSON, we'll use keys like name, date of birth, shoe size, social security number, and etc. Then we will do the same for each of our friends. That way we can get such an info as a schlong size about all of our friends by keys unique ID and schlong size if they have one, and you for some reason knew this number and recorded it. I don't know how exactly. There's a lot of reasons to use JSON structures. For example, like here, NASA wanted to tell you an estimated diameter in different measurement systems, so they sent keys like kilometers, miles, and etc. in one cell without duplicating lines. Or all days when that asteroid approached or will approach Earth. So we had to untangle that data a little, forming 3 tables, one of asteroid data, one for moments when asteroid approaches Earth, and one for orbital data. Thanks, you are cool, you've pushed through all the boring stuff, yeah. So what's interesting, we were able to find on NASA's data. First, there's 42,106 asteroids observed by NASA. I'll figure out by the end of this video how to pronounce this. And I don't think that any company have observed more. Asteroids have a parameter called magnitude. It's some kind of proxy for brightness of an object, and this is used to determine its size, because NEOs are often too small to be directly measured by telescopes. Scientists use the magnitude to estimate their diameter, with a smaller magnitude number for some reason indicating a larger, brighter object. So what if I will tell you mean, minimum, maximum values of it? We'll not get anything out of it, but here's the graph for anyone interested. Pause if you are interested, I don't know why. Much more interesting measurements will be diameters. Estimated diameter in meters can be up to 131 kilometers. It's like 159 Burj Khalifas or 1% of Earth's diameter. What this means? Let's imagine something 1% of your size will hit you, yeah? It's like diameter of AMR. Weapons used for attacking hardware targets. Basically, it's like shooting you with anti-tank rifle. Why do we have min and max measurements? Can't we just tell the number? How much is its diameter? No, Bobby. We can't measure something so small so far. It's hard as hell. Yes, Bobby, this is a small by cosmologic standards. Don't measure your pee-pee to cosmologic standards, Bobby. Measure your mom. Sorry about this joke. Most of asteroids are quite small. Yes, 100 meters are small on cosmologic standards. So let's look at the biggest and coolest one. Yeah, 2004 LA 33. There's no documented close approach date. It isn't hazardous, it's just too far from us. Don't worry about it. By the way, yes, you can check such visualizations just as we've showed to you on NASA's website. And in the dataset you have links to find details about any of the asteroid. I've said hazardous. What does it mean exactly? It is an asteroid or comet with an orbit that brings it close to Earth, and it must be large enough to cause like significant damage. So that's why our previous asteroids isn't classified as a potential hazardous, but we have 2,724 potentially hazardous asteroids. Maximum diameter of an asteroid that's dangerous to us, it's like 9,079 meters, and average diameter is 679 meters, or like 6 to 7 football fields. Yeah, we'll find out when exactly they will kill us a little bit later. Now we will open a new page in our research, asking ourselves, how does they move? Will they touch or kill us? And the most importantly, when? At first we'll look on what are they even orbit. Yeah, of course most of them orbit Earth, second place Mars and third place Venus, but how does the graph look for all the dangerous asteroids? Which orbit is scarier? Of course it's still Earth in the first place, but Venus moved quite far. The biggest proportion of dangerous asteroids is not Earth, but on Saturn for some reason. So technically its orbit is scariest, with 20% of observed NEOs as are potentially hazardous. Of course we would like to see when we expect most of unique asteroids, but sadly it's based on just the fact that we see more and more asteroids with each month. So we can't conclude anything almost. But we aren't interested in the question how much asteroids flying close to our planet is fact. We're interested in the question how much of them hazardous for us. When will we see an apocalypse, right? First, let's check how much of them are hazardous. And yearly we see around 350 potential hazardous asteroids close to Earth. How did we not die? Based on the internet, asteroids should be 11 to 12 kilometers wide to destroy us. So let's remove all asteroids that are not in this size range. And we got nothing. Not even one. So there will be no asteroid destroying Earth that we can see or governments and scientists hide from us. I would hide everything from us. We are dumb as fuck. Since I can't focus on one thing, now my attention span will help us to understand sizes of asteroids. For example, Chelyabinsk asteroid was 20 meters. And it was quite harsh and disturbing. So it was like 20 meters, yeah. Why is it interesting? Because astronomers estimate that around 60% of near-Earth asteroids that larger than 140 meters are still unknown. But all of this is small stuff, and in our case, size matter. So what will happen if the biggest hazardous asteroid, on opinion of NASA, will hit us? And I found the tool for that. The biggest one is Florence, with diameter up to 9 kilometers. So if it will hit Earth in London, crater will consume it. Building will collapse on whole south side of England. Half of France, Belgium and Netherlands. Anything that's built from wood will collapse up to Russia and Africa. Glass will be knocked even on Greenland for some reason. Anyway, whole England, Netherlands, Belgium, France will not care, because on this radius even clothing will ignite of the fireball that asteroid will create. Half of the planet at least will shake, but Europe will be wiped by power of an earthquake in this region, so no worries about it. So when it will be close to our planet, yeah? September 2nd of 2057. At around midnight, 41 minutes. And do you know how close it will be? 7.5 million kilometers from Earth. So okay, this is not as interesting as we expected, so let's check when the asteroids will be close to Earth in foreseeable future. So now the most important moment. When do we have the highest chance of giant asteroid hitting Earth? First thing I would like to tell you, thank God astronomers believe that all near-Earth rocks and comets larger than 0.6 miles or 1 kilometer, right, have already been found out. And none is on the trajectory to hit us anytime soon. We could believe them for sure, but do you? Do you? Closest one hazardous ever recorded to us will be on 2029. Its name Apophis. April 13, 2029. is the day of its passage, and distance from us to it will be 38,000 kilometers. Sounds like a lot, for sure, but for you to understand how small this distance is, from Moon to Earth distance is 384,000 kilometers. So it will fly 10 times closer to us than Moon. Size of this asteroid estimated up to 900 meters. According to modeling, such an asteroid would have a permanent crater more than 11 kilometers wide and more than 620 meters deep when it impacts. Devastating tremors of magnitude 7.4 on the Richter scale would go through the planet crust and would still be felt by humans as far as 500 kilometers from the impact site. The air pressure wave would shatter windows more than 1,600 kilometers from the impact site. For example, if London were ground zero, windows would be shattered in France and in the Netherlands. So yeah, based on my calculations, this is closest thing to asteroid apocalypse that we could see. Please don't panic. Calculated by NASA that it will fly past us. But yeah, situation is insane that it's the closest moment. Please don't panic. Calculations say that it will fly past us. But yeah, situation is quite insane. It will be the closest possible point where people will feel the breath of huge asteroid killing a lot of us. And if you want more research of government lizard secrets or space datasets, leave a like, subscribe, and bye!